Today we're talking about reflections. This is the beginning of chapter 3. Chapter 3 is all about transformations. So reflections, rotations, translations. We commonly call those as flips, slides, and turns. A reflection, which of those would it be? Flip, slide, or turn?
Flip.
Yeah, it's a flip. So the first thing we need to do is to define transformation, image, pre-image, isometry, maps, prime notation, orientation, and reflection. Get those defined in your book. Pictures will help you out. Okay, hopefully we won't have to define as much every day. But transformation, what do you got? Good. It's a change in position, shape, or size. Now the first few transformations that we're going to talk about are called isometries. Okay, so when you're dealing with the three first transformations, reflection, translation, and a rotation, those are all isometries. What's an isometry? What's it mean when it's an isometry? Emily? Okay, good. A transformation which the original or the pre-image is congruent to the image. So your original figure is congruent to the thing that's been transformed. Okay? So we have our transformations, we have our image, which is our original or our item that we transformed, our pre-image, which is our original, our isometry, meaning they stay the same. Something that maps onto another thing is it moves, or it's like if you were to cut it out, you would be able to set it on top of that item. And we'll show that here in a minute. Prime notation we'll show in a minute, and orientation. Okay, and then we'll demonstrate a lot of reflections today. So let's talk a little about orientation. This is something that's going to come into play quite a bit when we're going through our transformations. If you look at the orientation of a figure after a reflection, you'll note that this, if I've reflected bug into B prime, U prime, G prime, it's very creative there. Okay, so B prime, that's how we read this. U prime and G prime is it's been reflected from BUG. Okay, so this is flipped over. This bug maps to this. This is prime notation. We put these little marks here to show that those are the reflected points of these 3 points. Okay, these 3 points right here have been reflected over here, and we've drawn our line and we have a reflected shape. Notice the orientation. If I was to go from B to U to G, I'm going clockwise, or I'm going from the left to the right. Notice in a reflection, now if I go from B prime, U prime to G prime, I'm going counterclockwise. The orientation has changed. So orientation refers to if you were to move around, in what order you move in. Okay, so from B to U to G, you're going clockwise. For those of you who understand the face of a clock, a lot of you don't use them anymore, but there's 12 o'clock. You move around this way, that's clockwise, versus your face of the clock, you move around this way, counterclockwise. Okay? So this one's counterclockwise, this one's clockwise. That's a property of a reflection. The orientation changes. So when we're done with this unit and we're looking at all these different transformations we study, and I say, what is this transformation? From this pre-image to this image, what has happened? You should be able to look at it and go, well, I automatically know it's not a reflection, or, hey, that's been reflected based just on orientation. If the orientation has changed, somewhere along the line, it's been reflected. Okay? So we want to focus on orientation. It helps us determine if something's been a reflection. Okay, any questions there? All right, so let's talk about your assignment. Let's look at your assignment. I want to try some problems. This is example 1, problem 1. It says in the diagram, S prime, T prime, U prime, that's an image of Stu. Okay? Use the images of angle S, or name the images of angle S and angle U. So Stu maps on to Stu prime here. Okay? what corresponds to angle S, what corresponds to angle U. List all the corresponding sides. I want you to work with a partner to do that right now, please. So, oh, that's not the right problem. Let's go back. Let's try that one. All right, so this, I know, this is pretty cool.
That's fun.
So U, isn't that cool? I know. Corresponds to U prime. Now I know that the shapes, they're not the same. They're not in the same location in terms of this being here and that being there. Okay, but this angle, U, corresponds to U prime. S corresponds to S prime.
Why are you using such a big marker?
Because then I can see where the key is, where it's at.
Oh.
I'd use this, if I use that, see how small that point is?
Yeah.
Can you guys see that?
Yeah.
Can you see that way back there, Hannah?
No. Yeah.
See, when I give this to you for you guys to write on the screen, it's going to be tough for you to see where that's at. Okay, corresponding sides. So let's erase some of this stuff here. Yeah, it's pretty cool. Check that out.
Oh, it's gone.
Oh, I know. That's so much better than the pen that I use at the board here that doesn't erase. So, yeah. All right, so corresponding sides. Give me one set. Yeah.
ST and S prime T prime.
This is very tough to write with. Okay, so we've got ST and S prime T prime. Holy moly. Yeah, that's not good writing. All right, what else do we got? Yes? SU, hey, that's much better. Dude, feeling like all pro there. And S prime, U prime. Oops. Yeah, that's not going to be good. I'd scribble that out, except for it doesn't.
Just use the other pen.
Use the what?
Just like use the other, like a felt tip.
Yeah, use the big
Using
pen.
ballpoint.
Sometimes it's easier to write with a large pen.
I'll experiment with it. What's the next one? One more. Ethan, what do you got?
I got T, TU, and then T prime, U prime.
TU and T prime, U prime. Oh my goodness. That's really not good. But I know you guys will have grace with me right now. All right.
You have bigger handwriting with that.
That's really bad. Okay.
I think it's
Good?
just maybe you have to like turn around.
Okay.
To look
Holy
at
moly.
it. Or like us.
All right, next one. I want you, for that triangle, draw its reflection in each line across the x-axis and y-axis. So this is where your plastic and pin's going to come into play. So everyone find those things.
Plastic and white. I don't understand.
Okay, so everyone has a pen that works. Okay? So what we're going to do is we're going to take our plastic and we're going to first start by having some kind of way to show where we're at. So what I do is I trace the origin like that. Okay? I just put a little piece. So if you don't have pens and plastic with you, you don't carry one with you at all times, eventually you'll get used to doing this in a coordinate plane and it gets a little easier, but the pins and plastics help out right now. And so when I'm tracing this figure, really all I'm going to do is I'm going to label its vertices. That's a little easier. So there's M, there's N, and there's L. So I just put points on those. So if I slid it over, that's what it would look like. Okay? And now I need to reflect it in the x-axis. Now, remember, the x-axis runs right here. This is x. So when I'm reflecting across the x-axis, that means I am essentially flipping this over. Okay, that's a reflection. Now note, because I have the crosshairs there, I know where to line it up at. Okay, now if your ink's a little wet still, you could press really hard and see where it's at, but the line wasn't wet. So what I'm going to do is I'm going to kind of look at the coordinates. I know that this M prime is right on N, and N prime is right on M. And I know that L looks like it's the coordinate 1, 2. So if I was to reflect it on the x-axis and I wanted to trace those points, I could, or put those points, I could go 1, 2, that's L prime. You really shouldn't use your overhead pen, but I left my other pen at my desk. So N prime and M prime. And then you take your trusty straight edge of some sort and connect your points. Now I see a lot of students in other years, they shade it and they label it because they're crafty like that, and you're welcome to do that. I'm not going to do that, but that's my first one there. I've reflected across the x-axis. Okay, so I'm going to walk around real quick, make no relation to Optimus. All right, here we go. Good job. Across the y-axis. Now, oh, gotta find it. There we go. Okay, so there we have it. Yeah.
Okay, when it says across the y-axis, does it want us to reflect the original across or the?
You're reflecting the original across the y-axis. Yep. Okay, so we're going to take my original that I have, and I'm going to flip it across the y. Now, when we go across the y, remember the y is this way. Okay, it's like the seam of a book. Okay, so it's like turning the page. So when you're reflecting, it's like you're flipping the page there. Okay, and there it is on the y-axis. Now note where your points are. Okay, look at your coordinates. That helps out. So it looks like L prime prime would be at 1, -1, -2. So you guys heard me say, call it L prime prime. Oops, missed that point. There we go. So we're going to call that L prime prime because it's my second reflection. Okay, and it looks like M prime prime would be at -3, 3. And looks like N prime prime would be at -3, -3. Okay. We draw it in. There we've got it. Okay, I'm going to focus heavily on these two figures right here, on the reflection over the y-axis. I want you guys to note that if I were to connect L prime prime to L, and M prime prime to M, and N prime prime to N, notice they cross the line of reflection at, what angle did they cross that line of reflection at? Yeah, 90 degrees. If you connect an image and its pre-image, crossing the line of reflection, it should cross at a right angle. So that's a quick check. Okay? It should also be equidistant from that line of reflection. So notice that this is 3 units. This should be 3 units. That's 1 unit. That should be 1 unit. 3 units, 3 units. So some of you won't even need to use the plastic. You'll look at this and you'll go, well, I know it's going to cross at a right angle. This is 3 units from that line of reflection, so I just need to go 3 units this way. And this point's 1 unit from the line of reflection, so really I just need to go 1 unit that way. Okay? Now it's easy when the line of reflection looks like that, but what if I were to say, hey, this is your line of reflection? Okay, a y equals x line. It makes it a little more difficult. Okay? You're going to see that a bit. Any questions? All right, one other cool thing about reflection. So let's take this. This is number 7. Number 7 said, where should point P be placed on a line L to minimize the distance from QP to PR? So in other words, if I were to put point P somewhere on this line, where could I put it so that it would be the shortest distance if I drew from like Q to P and then to R? Where would the shortest distance be? Why don't you talk with your groupies about it? Let's talk. So I have went and took this shape that we have, the figure, and I've just twisted it, or I've traced it and I've twisted it. Okay? Now, what I'm going to do is I'm going to take and reflect, ignore these other points I still have on. Oh, come on, I don't want anyone to get grossed out by saliva or anything. Just saying. Okay? So, if your neighbor did not get a piece of this and they're using spit to erase theirs, yuck, I know. Okay? Now, what I'm going to do is I'm going to take Q and I'm going to take R and I am going to reflect them. Now, in order to reflect them, I need to have this line so that I can actually get it to line up here. So I'm going to trace those as well. Okay? Anytime you're reflecting, you should really put some kind of crosshair on there. And I did not trace that on mine, so I think I should have put that first so that I could line it back up. Yep, good. Okay, so notice I put that there. All right, so now I can reflect those points. I'm going to go ahead and reflect those over. They're going to cross at a right angle, and they're going to be equidistant away, and I'm hoping that my pen will... it kind of left a mark right there and right there. Okay, so that gave me my Q prime and my R prime. And now I'm going to connect those points. So I'm going to connect Q to R prime. And then I'm going to connect Q prime to R, or R to Q prime. Oops, that slid a bit on me. There we go. All right, and you'll notice they cross at a point on that line. That point we are going to label P. So now I have a line from Q to P and P to R. And what's really cool about this point, if I can get this to work right, it's very, very tough to do up here. I have a mirror. Can everyone see that mirror?
Yeah.
Okay. I have a mirror, and let me zoom out here. I have a mirror and I have a laser. Rory, I might need your help. Okay, I might need you to just hold that ruler right there. Okay? Yes, I do have a laser at school. All right. Now, if I... Oops, I need to hold my mirror somewhere else now that I'm thinking about it. Let me try this a different one. If I put a mirror right at that point, P, and I shoot a laser from P, or from Q to P through R, it should actually cross. I don't know if I need that ruler. It should cross and hit point R. So if you can see that, you guys have to tell me how you see it because I can't watch the screen. But
It's like a really, it's very apparent.
all right, let's see.
You can see it.
Yeah.
Isn't that cool?
Oh, it like goes out of the Whoa, and then it like bounces off.
Can you see it
Yeah.
almost going through R there?
Wait, if this helps shooting in lasers to school tomorrow,
No. Do not bring lasers to school. That's against the school policy. But
Then why do you get
because I have a degree. Okay? So,
He has a degree.
yep. They teach you how to use these things in college.
What does the laser even do? Like, how is her name?
All right. So the point is actually point P, but I know. So hopefully, see, the point is when you guys start studying a little more in science, you start learning the angle in is the angle out. Have you heard that before? So your point of reflection is the point of or your angle of reflection is the angle of refraction. Have you heard that before? Okay. Well, anyway, what that means is as you shoot, and you notice mine was off a little, but my point, I didn't quite hit Q. So the angle that I go in, this angle right here, is going to be the same as that angle right there. Okay? The angle I go in is the angle I'm going to come out of. And that's going to make it so it's a perfect reflection. It's like if I stood right here and Blake stood right here. Okay? I stood here and Blake stood here, and Blake has a dodgeball. And he's like, you know, I've studied this in math, so what I'm going to do is I'm going to do a trick shot. I'm going to hit the wall and then hit McCoy right here. Okay, so Blake's, he's got it all planned out. He's used this cool protractor, and he's like, all right, McCoy, and he hits it really hard and hits it right here. Good. Now, Blake's got to use muscle, otherwise it's just going to bounce to me, and it's not going to hurt me. But I'm just saying. Right? Okay. All right, very good. Any questions? Applying that concept. Let's apply that concept into a different figure here. So number one on the mixed side, where should point K be placed on LN so that MK plus KO is minimized? So you got to think, you're going from M to K to O. So where are you going to put a point on that line? Work with your group. How are we doing on it? Who has it?
We're working on it. I'm kind of getting it.
Okay, for those that are struggling, hey, what's helpful when you're doing this?
Related to the last one.
Plastics easy or helps out. What if we were to take and maybe ignore that this is a triangle? Right? Maybe try to, the best you can, ignore that there's this actual other side that we see there. See what I'm talking about? So now I'm just going from M to somewhere over here, out to O. Maybe ignore these other sides. Okay, if you're able to do that, that might help out a bit. Just think of them as points. So you want to go from this point to some other point on this line to that point. These sides don't matter. Okay? Can I borrow your plastic?
Yeah.
Thanks. Oh, that won't work. That doesn't work for me.
Because yours is...
I know. Can I borrow your paper?
Wait, for some of these, isn't it going to be hard to
think
be
it's
exact
okay.
because when you reflect out a lot of the times you can't get it perfectly because of
It will be. I agree.
Is that
Yeah,
okay?
that's a good point.
So what do we do about that? I mean, because mine is
Let me talk to the whole class about that.
mine's like right here. I just got it, but it's like super, just a tiny bit above the line, so I don't know if that counts.
Okay, so checking it out. There's our pen and plastic, or our plastic and paper there. We've got it traced. Rory's flipped it right over, and got our points there. Now, as Emma's pointed out, you're not going to always be exact because we're having to lift the plastic and put the points. Just do the best you can. Okay, if we would use a more precise method if we were actually building something or using it to do perform calculations, but for what we're doing, we're just practicing finding these reflections. Okay, so we got point K. Well done. So M to K, K to O. Thank you. Oh yeah. Okay. So if you look at problems 7 through 10 there, okay, a little confusing usually for students. Says given the points T, A, B, draw a triangle tab. Well, then they have the shape over here. This is not triangle tab, I hope. I hope you realize that. Right? As soon as you start plotting the points, you'd be like, hey, that doesn't make sense. Okay? But that's not triangle tab. We've got to do these things to triangle tab. Now, just so that we're very clear about something, if I am plotting triangle TAB, so what, 2, 4, -3, and -4, and 0, -4. All right, if I have those points, and I am, stay with me here. Stay with me. If I am reflecting those points across hey guys, the only reason I'm up here explaining this is because most of you have no idea, or you'll do that wrong. So right now, everyone show your neighbor where x equals -3 is, where that line is on your paper.
Just where x is -3 and then it's an undefined line. Yeah. Undefined line.
Okay, everyone show me with your arm. What's x equal -3 look like? Some of you are right. Some of you have no idea. Some of you are kind of guessing. X equals -3 is like this. It's a vertical line, meaning it goes through the x-axis at -3. This is the line x equals -3. I'm reflecting over that line. Everyone show your neighbor where y equals 4 is. Okay, that's what your arm says. Where's it at on the y-axis?
Over, it crosses the
Up 4.
negative.
All right, see you later.